Hello, welcome to this video. This is 2-4 and we are going to talk about differentiability. When can we go ahead and differentiate or find the derivative of a function? Alright, so let's go ahead and do some recap. The first thing that we're going to talk about is continuity. Now remember, if a function f of x is continuous at a x value c, then what is true is that the limit from the left as x approaches c from the left of the function is equal to the limit of f of x as x approaches c from the right. The left and the right have to touch. This just shows us that the limit exists and that I don't have a jump. What also has to be true is that f of c, where they meet, that the function value there exists, f of c exists, and furthermore, the limit of the function as x approaches c has to be equal to f of c. And right here, this is your definition of continuity. Continuity definition. Okay? So if that's true, then your function is continuous. And in essence, plain and simple, if I were to draw a function f of x is continuous at x equals c. When you can draw the graph without lifting up your pencil. Lifting up the pencil or stopping. Okay? So that's what it means to be continuous. Schwarberg, I thought we were talking about differentiability. Well, I'm giving you a recap because we're going to use that idea today. So differentiable. We say that a function f of x is differentiable at x equals c if f prime of c exists. So f prime of c has to exist, i.e. there must be a derivative. Now for a function to be differentiable at x equals c, two things must be true. The function must be continuous. It has to be continuous at x equals c. Additionally, the derivatives from the left and the right as x approaches c must approach the same value. Must approach the same value. Okay, and graphically what's going on is that the slope must be the same value from both sides. And we'll go ahead and we'll look at this here in a bit. Okay, so right here, AP exam tip, they give us some hints about what it means to be non-differentiable. Non-differentiable. And actually, I'm going to have you write this word here. Non-differentiable. Non-differentiable. So when is something non-differentiable? Well, we already talked about the continuity. So if there's a discontinuity, it's not differentiable. So the first one being a whole, the second one being an asymptote, and the third one being a jump. So if those three things occur, it's not differentiable. And then 4 and 5 come here, looking at the slopes of the graph. We look for anything that's not continuous as well as has a sharp-ish corner. Sharp corner, so, or a sharp turn, so 4. Sharp turn. And then if it also has a vertical tangent line. Number 5, a vertical tangent line. Vertical tangent line. Okay, so write those down. Those are the 5 things that prevent us from taking a derivative. And visually, let's go ahead and kind of look at these here. So first I want to point out a sharp turn, which is a very, very common graphical non-differentiability kind of characteristic. So right here at x equals 9, not differentiable because I have a sharp turn. X equals -6. The slopes are not the same from the left and the right. Do you see how it drastically changes? Okay. 2, x equals 2. There is a non-differentiability. And then, okay, that's it for sharp turns. We're also going to go ahead and let's look at our discontinuities. I have a discontinuity here at -2. Not differentiable there. Also at 5, do you see here how I have a jump? Not differentiable there. Okay, and then lastly, the last one, and if I'm highlighting these, right? So here's all our discontinuities, whole asymptote jump, which we don't have the asymptote. The last one, a vertical tangent line. This is where our graph kind of goes flat vertically, right? So if I was to draw a tangent line there, it would be a line that goes straight up and down. That's a vertical tangent line. That's non-differentiable because the slope of that is undefined. It's vertical. It's a straight line, right? No slope. Okay, so here we go. Example number 1, which we kind of already did. Find all values of x where the function f of x is not continuous, and then classify each discontinuity. So not continuous, that's going to be x equals -2, and that is removable. And then x equals 5, that is non-removable. That's a jump, right? Non-removable. Okay. Example number 2, find all values of x where the function of f of x is not differentiable. So we kind of already talked about these two, right? X equals -2 and x equals 5. And that's because these are discontinuities. And then we have the 3 sharp corners or sharp turns that we talked about at x equals -9, x equals -6, x equals 2. Okay, so x equals -9, -6, and 2. And then these were what we'll call sharp turns. Oh my gosh. It's a Monday. I don't know if it's a Monday for you, but it's literally a Monday for me right now. Sharp turn. And the Packers lost. I'm distraught. Ugh. Okay. And then lastly, x equals 7. This is a vertical tangent line. Okay. All right. So those are non-differentiabilities, non-differentiable points at those x values. Awesome. Okay. So let's go ahead and look at a graph and see how this applies. Example number 3, consider the function g of x above. Okay, this is g of x. Normally they label it. Pay attention to the labels. That's important to know what type of graph you're looking at. Find the following values if possible. Okay, what is g of -4? Okay, they just want the function value at -4. So 1, 2, 3, 4. That is right here. And that looks like 1. What is g prime of -4? G prime of -4. Well, that's on a straight line, so the slope on that line is the same everywhere. So it looks like we drop 2, and we go from -6 to -2. That's 4, so that is -1/2. -2/4, right? -1/2. C, what is g of 3? G of 3, okay, well here's 3. Function value looks like 2. Just the function value. And these questions will do that. They'll alternate between actual, asking you about the function, and then asking you about the slope. And we'll see a really tricky case coming up. What is g prime of 3? Oh, they want the slope at 3. Hey, that's a sharp turn. So g prime of 3 is undefined. It's not defined. Undefined. Not D&E. Not D&E. Not. Only limits do not exist. Only limits do not exist. G of -2. That's just the function value at -2. Isn't that 0? Okay. It's right here. 0. Okay, what is g prime at negative 2? Well, let me remove my mark so you can see this. Isn't that a sharp turn? So this is undefined. The slope coming from the left does not match the slope coming from the right. What is g prime of 2? Hey, here's another sharp turn at 2. That's undefined. Right here. That's undefined. And then g prime of 4. G prime of 4 is right here. Okay, and what's the slope on this line? Well, again, we're dropping 2, running 2. That's negative 2 over 2, which is negative 1. That's the slope. Okay. All right. Here we go. Okay. So here is example 4. And I'll have you do a practice, try some of these on your own here in a second. But I want to point out a little nuance on this problem, okay? One, they say the graph of the function h prime of x is above. This is a graph of the derivative of h of x. But what does h of x look like? I don't know. I don't care. I don't care. They give me this. I'm going to use this information that they give me. This is h prime of x, okay? So they say use the graph of h prime of x to find the following if possible. So they say what's h prime of negative 1? Of negative 1. Well, this is h prime. So I'm just going to treat it like the function value. Wouldn't that be right here? And that point is 3. What's h prime of 1, they ask. That's right here. Okay, well that value is 1. What's h prime of 2? Oh, I have a hole there and no function value at 2, so this is undefined. And then what's h prime of 4? H prime of 4. What is h prime of 4? Where are we at? Right here. You know, that looks like 1 or 0.5. Looks like it. But I'm going to be smart. I know that's a straight line. And the slope of this line, if I go ahead and calculate it, looks like we're rising 3 and running 2. So, yep, so 3 over 2. So for each x value, we rise 1.5, right? 3 over 2, isn't that 1.5? So for each x value, we go up 1.5. Yep, very good. So from negative 1, that would be positive 0.5. AP question loves to ask you those questions about random points in the middle of a linear line, and you have to use the slope to find out those values. Okay, I'm gonna have you do an example coming up. G and H are gonna be you guys. But question E. What's h prime of negative 5? Oh, again, another one of these. Take a second, pause me. I want to see if you can find out what is h prime of negative 5. What's that function value, that point right there? Okay, hopefully you went ahead and did that. It looks like we drop 1 and we run 4. So that's going to be a slope for that line is negative 1/4. So we drop a quarter every single time. So 1.5 is the exact answer. If you said anything else, you're wrong. 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 Watch me have like an error here and be completely wrong. 1.5. That's it. Yeah. Okay. So we go from 2, we drop a quarter, drop another quarter. So what would this point be? 1.25. Good. Okay, and then lastly, now F, they ask about h double prime of negative 5. Oh, so they want the slope of the slope. Okay, so what's the slope of h prime here? Well, didn't we just find that on that line? H double prime at negative 5 is negative 1/4. That's the slope of the line at negative 5. So they'll like to play tricks on you. They like to give you a derivative graph on the AP test. You'll probably have a question where they give you a graph of a derivative, and then you have to kind of understand that when they ask you about double prime, they're asking you about the slope of this graph. Okay, I'm going to pause here. Go ahead. Please find h prime of negative 3 and h double prime of negative 3. And I'll give you the answers here in a moment. Okay, hopefully you paused me. H prime of -3, that was very, very straightforward. That's 1. And then the slope there, well, that's a sharp turn. This is undefined. Undefined, not defined. Okay. Here we go. H double prime of -1. What's the slope at -1? Well, hey, isn't that like a maximum right there? So the tangent line, the slope of that would be 0. The slope of that is 0. It's neither increasing nor decreasing. That's the ball being thrown up in the air, stopping right at the top. H double prime of 4. What is that slope? Well, we already calculated the slope there. We said 3/2. Okay. And I'm going to let you try these last two. Go ahead, please try K and L, and I'll show you the answers here in a second. All right, hopefully you tried those. H double prime at 2. Well, H double prime at 2, there's a hole. So if H prime doesn't exist, if it's not continuous, then the derivative doesn't exist. So undefined for H double prime at 2. And then they asked about H double prime of 1.17. And you're like, what the heck? 1.17? 1.17, that's like somewhere like in here. Yes. So they want to know what is the slope right here. Well, how am I supposed to know that? How am I supposed to know where 1.17, it's a straight line. The slope is the same everywhere. So what's the slope of this line right here? -1. There's your answer. Did you get it? I don't know why it's in red. -1. Okay, hey. That is it. That is it. All right, just to recap, what you should have learned in this lesson is that in order to be differentiable, it has to be continuous, and the slopes from the left and the right have to be the same. Those are the two things. Now, where is it non-differentiable? Right behind me, right here, right here. If you have a discontinuity, such as a hole, an asymptote, a jump, it's not differentiable. Also, if we have a sharp turn and a vertical tangent line, it is not differentiable. Give me a thumbs up if you like this video. Subscribe for more awesome math content. I'll catch you in the next video. Peace.